The Methods and Materials section provides a detailed description of the experimental procedure. The goal of this section is to provide the reader with a clear understanding of the actions you performed during the lab and what equipment you used and how, so that, using only your instructions, they would be able to successfully perform the experiment. This section should be clearly written and straightforward. Be careful not to include so much unnecessary detail that you shift the focus from the most important parts of the procedure by cluttering the narrative with extraneous information. Before we look at some examples of this section, let's go over a few tips that will make writing this section easier. Tip number 1. Write this section first. The first tip is to write this section first. It's often the easiest to get out of the way, and you can use the lab instructions as a guideline. Don't wait too long after the lab to get started. The fresher your memory is, the better your explanation will be. Tip number 2. It's not a list. Lab instructions, given by your professor or printed in a manual, are generally presented as a numbered list. But when you write, instead of numbering steps, write out what you did in a narrative format, like you're watching someone else do the experiment. This leads us to our third tip. Seriously, no lists. Many students make the mistake of including their materials as a bulleted list in this section, similar to the one on the lab handout. Instead, name the materials and equipment used as they arise during the procedure, describing how they were used. Tip number 4. This is a big one. Use passive voice. Though there is some variation in requirements, and it is always important to check with your publication or instructor, many instructors and journal publishers recommend that you use passive voice for the Methods and Materials section. Engineering journals require the use of passive voice for the entire paper. Typically, we communicate what we see, do, or hear using the active voice. In the active voice, the reader is given the subject, the person or thing responsible for the action, at the beginning of the sentence, followed by the verb and the object of the verb. An example of a sentence in the active voice is, "The students measured the velocity of the ball near the point of impact." In this sentence, we are given the subject noun, the students, immediately followed by the verb, measured. In active voice, the verb usually comes pretty early in the sentence, right after the subject. Passive voice is used often in scientific writing as a way of prioritizing the science, rather than the researchers who conducted the experiment. It can also help to maintain objectivity and flow, and to prioritize the most important takeaway from the sentence. In passive voice, the subject may be eliminated from the sentence entirely. Instead of placing focus on who performed the action itself is emphasized. To illustrate how putting a sentence in passive voice shifts that focus, let's put the previous sentence in passive voice. You'll remember, the sentence in the active voice was, "The students measured the velocity of the ball near the point of impact." Putting this in passive voice, we get, "The velocity of the ball was measured near the point of impact." An easy way to check if a sentence is in passive voice, if no subject is included, is by adding the subject back to the end of the sentence. We could say, "The velocity of the ball was measured near the point of impact by the students." However, it's much more fun if we replace our subjects with zombies and say, "The velocity of the ball was measured near the point of impact by zombies." As you likely noticed, the passive voice version of that sentence focuses the reader's attention on the measurement being taken rather than who took it. By keeping the reader's focus on the subject at hand using passive voice, you can maintain good flow in your scientific writing. Tip number 5. Take good notes. As a student, one of the biggest struggles I have while writing this section is remembering everything that I did. If the professor wrote everything we had to do for every single step of the lab on the instructions, each handout would be several pages long. Since the instructions don't generally include every action you must perform, you should always bring a printed copy of the lab handout and take notes in the margins to document anything you do that isn't explicitly written in the instructions. This is also a good way to keep track of any mistakes you make. Taking good notes will help you to explain the procedure more clearly and, in later sections, describe any potential sources of error. Tip number 6. Use pictures and diagrams. Pictures and diagrams can be very useful in the materials and methods section, especially when it's difficult to explain complex arrangements. In labs where the instructor allows it, you can use your phone to photograph configurations, settings, and setups. Even if you aren't allowed to use photographs in the report, these photos will help jog your memory as you write. You can also use them to help you create accurate diagrams, which will aid in your explanation of the procedure. Tip number 7. Keep it simple and scientific. It is important to have balance in this section. Too much description will negatively impact clarity, but too little description will leave the reader unable to replicate the experiment. Remember KISS. Keep it simple and scientific. Make it scientific. Provide enough detail that someone outside of your lab, but with a background in science, could easily reproduce the experiment and gather results the same way that you did. But keep it simple, so that there is not so much unnecessary detail that it's difficult to understand how the procedure unfolded. Tip number 8. Know your audience. Knowing your audience is an important factor in deciding how much detail to add. You can assume that the person reading your materials and methods section has taken at least as much of the course as you have if they are trying to reproduce your work. They will have a working knowledge of the procedure, but may need to know specifics about the materials you use so that they can determine if a mismatch between their equipment or supplies and yours caused a variation in results. For example, in a chemistry report, it may be important to specify whether you used laboratory-grade, high-purity hydrochloric acid instead of the same kind of acid available at the hardware store, muriatic acid, which may have more impurities or a different pH. You should also assume that your reader may have a different brand of equipment that performs the same function. Since their equipment may be different, it does them no good to read a detailed list of operator instructions, like turn on the microscope light using the red switch on the back right corner of the microscope. Assume that your audience is competent enough to know how to use their equipment or consult the manual for specific instructions. Tip number 9. Avoid barking orders at the reader. Another common error in writing this section, especially if you are falling into the trap of creating operator instructions, is that it will sound like you are ordering the reader to do each step of the experiment, instead of reporting what you did. This usually happens when students are trying to move from the numbered task list to providing a narrative description of what happened, as though they were watching the steps and taking notes. This frequently occurs when students are not using the passive voice in the methods section, or are trying to create a form of numbered list by saying first, second, third, etc. Tip number 10. No humans in the methods section. Of all the sections in the lab report, the materials and methods section seems to be the most prone to slipping out of the passive voice because you did the work. Check your text for I and we and change sentences where those words appear to the passive voice. For example, next, we measured the sample using a caliper could be changed to the sample was then measured using a caliper. Lab partners or research teams sometimes show up too, as in, my lab partner used a multimeter to measure the resistance of the circuit. Written properly, this sentence should be something like, the resistance of the circuit was measured using a multimeter. If it is important to specify that something was done by hand rather than by a machine, for instance, if you tightened a bolt with a wrench instead of an air-powered tool, state that the action was done manually. Instead of saying, I tightened the bolt by hand, say, the bolt was tightened manually. Generally speaking, you should not mention any humans in the methods and materials section unless you are performing an experiment on them. Let's look at some annotated methods and materials section examples provided by a professor. Feel free to pause the video if you need extra time to read. Think about each example and write down any issues you notice. Keep the 10 tips we just reviewed in mind as you read. Here's an example where the team had a very busy day. Take a moment to try revising this paragraph on your own to remove any references to humans. Remember to use passive voice effectively to prioritize the most important aspects of the research procedure. Here's a sample revision provided by a professor. How does yours compare? Let's take a look at a professor's comments on a procedure written by a student for the same experiment. You may notice that this example has some basic errors that we discussed in the previous section. It provides a lot of information that may not be relevant to an outside group conducting the experiment, including some operator instructions. Also, it fails to maintain passive voice throughout. Perhaps more importantly, though, it does not clearly discuss how the lateral expansion and percent shear were found, which is vital information for the calculation and interpretation of the results. Now that you have a clear understanding of how to write an effective methods and materials section, let's move on to the introduction, where we will draw the attention of our audience, provide some context and justification for our experiment, and incorporate and explain our objective and hypothesis.